So in this video I want to prove the formula for our conic section of the parabola. And by the conics definition we can look at a parabola a little bit differently than what you normally think of it as. Hopefully you're familiar with it as this U-shaped graph. But let's think of it a little bit differently. Let's say that we have a point that is directly up from the vertex of the parabola. Say this parabola has its vertex at the origin, 0, 0. And we have a point directly up from it that will be at the point 0p, where p is the distance it's gone up from the vertex. And let's say that we have a line below the parabola here, and that it's p distance away from the vertex in the other direction. So it would be the equation y equals negative p. Now if this is the case, we can define our parabola as the set of all points, where if we have a point, and we'll call our point xy, and we draw a line from that point to the focus, and then draw a line from that point straight down to the directrix, the distance or the length of those two lines are going to be equal. And the drawing doesn't show it perfectly because it's not drawn perfectly to scale. But let's try to see if we can derive what our formula for that will be. So if we want to do that, these two distances are equal. How can we get the distances? That's just our distance formula. Distance is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So with that in mind, we go to this. What's the distance of our first line? We'll call it d1. That's going to be the square root of our x-coordinate, we'll call it x, minus the x-coordinate of the focus point, which is 0. That's squared plus the y-coordinate of our point there, just y, minus the y-coordinate of the focus, which is p. And that's squared. Okay, with that in mind, now what is the distance of our other line? I'll call that line d2. Well, we're coming down to this point. Since it's a straight line down, that means the x-coordinate there is going to be the same x, but the y-coordinate is negative p. So that distance is going to be the square root of x, the coordinate, minus x, which is the coordinate of the directrix point, squared, plus y minus negative p squared. So that is the distance for our line d2. We're saying that we're going to define our parabola as being the set of all points for which these two distances are equal. So what can we do to try to get a standard equation? Well, let's first simplify this. On the left side we get the square root of x minus 0 squared, which is just x squared, plus y minus p squared. And on the right side, when we simplify, x minus x will be just 0, and that's simply y minus negative p, which will be plus p squared. So now if we want to solve this and get it into a standard form, let's square both sides of the equation. We just clear those radicals. We'll get x squared plus y minus p squared equal to y plus p squared. Then if we multiply out our y minus p and y plus p, we'll get x squared plus y squared minus 2yp plus p squared. That will equal y squared plus 2yp plus p squared. So then if you notice, we have some terms on each side we can subtract off and cancel. Y squareds will cancel, p squareds will cancel. Now if we take this negative 2yp and we add it to bring it over to that side, we're left with just x squared equal to 2yp plus 2yp. And obviously we can combine those terms and we get our standard equation for the parabola. X squared is equal to 4py. So this is saying that if we have a parabola, the coefficient in front of y is going to be 4p. So we simply divide that coefficient by 4 and we get our p value. The p-value is our focus setting here in the center of the parabola, or centered in it, moved up from the vertex. And it carries a lot of interesting reflexive properties and different things we can do with it. So really, this x squared equals 4py is the same parabola we've worked with before, but we're just defining it differently with respect to its p distance to the focus and directrix, and this is just a different way of looking at the same parabola, defining it as a conic section.